So in the last couple of lectures, we talked about what's called compound interest, right? And the idea behind compound interest was you take a certain amount of money, you put in an account, earning interest at a regular interval, and you let it sit, right? You leave it alone for a certain period of time, and you earn money on it, right? And then now we're going to do a similar situation where the principal changes, only now where with compound interest, the principal changes because the interest gets added in every month or year or whatever the period is. Now we're going to assume that you are also putting money in. You are making regularly scheduled payments into this account. All right, this kind of an investment has a name. It's called an annuity. All right, so an example here. Suppose you put $100 into an account every month. And we actually need to make that a little more specific. Right? We're going to assume you put this into an account at the end of every month. If you do it at the beginning, it's a slightly different scenario. Right? So we're going to assume you do it at the end of the month, which is kind of a standard savings situation. Right? At the end of the month, hopefully you have this money left over. You put it in the account. You're going to do this for 6 months, and the account earns 12% interest. All right, now I want to know, what is the future value of this thing? Okay, well, let's think about how this works. We're actually going to play off of the compound interest formula here, right? At the end of month 1, you're going to put $100 into that account, and that account is going to sit there. You've got 5 months to go now at this point, right, before it comes to an end. So this $100 is going to earn interest for 5 months. Well, the compound interest formula tells me that the future value of this $100 will be 100 times 1.01 to the 5th power. All right, so that takes care of that $100 for the entire period. Right, now let's think about what happens next. At the end of month 2, you put in another $100, and that's going to earn interest for 4 months. So again, going to our old friend, the compound interest formula, this $100 ends up being worth 100 times 1.01 to the 4th power. We're going to continue this, right? Month 3, that $100 earned interest for 3 months. So its future value is 100, 1.01 to the 3rd. And we're going to continue, right? Month 4, month 5. You see the pattern now, right? Staying the same. The exponent is just changing. What happens in month 6? This is the weird month, right? This is the month you put $100 in on the very last day of the investment. So it earns interest for a squirrely 0 months, right? Which means its value is 100, 1.01 to the 0 power. 1.01 to the 0 power is 1. So yeah, that ends up being $100, right? Which is a little weird, but it's how it works. Okay, so what is the future value of the account? Well, to get the future value, I'm just going to add up all of these individual values. And I don't want to, it gets a little tedious writing all of this out. Notice that every value has a 100 in the front of it. I'm going to factor that out. All right, so the future value is 100 times 1.01 to the 5th plus 1.01 to the 4th plus so on down to 1.01 to the 0 power. All right, now here, if you're taking a slightly more advanced math class, you might actually go ahead and do the next step to really get to the formula. It requires a kind of unusual factoring step, right? You have to see how you can factor that in a way that is valid but very non-standard, right? So at this point, I'm going to kind of adjourn the process here. Although, just in case you were curious, sorry, let me get the final answer. This is 600. That got a little messy. That's a dollar sign. $615.20, right? That would be the end result. Okay, so what's our formula? Well, it's this thing. I don't know, this thing looks like a hot, flaming mess. But look, please, when you're doing these, don't let yourself get distracted by the complexities of the formula. It's just a formula, right? That really is all it is. It's got a lot of symbols we've seen already that we already saw in the compound interest formula. Doing these annuity problems is really going to be no different. We're going to identify that it's an annuity situation. We're going to pick out values for all the variables except for one. We're going to substitute them into the formula. Then we are going to be super careful with our calculator. In fact, I'll go ahead and do this now. We have an issue similar to what we saw with the exponent in the compound interest formula. You got to be really sure your calculator understands what's in the top and what's in the bottom of that fraction. So it doesn't hurt to throw an extra set of parentheses around the numerator and denominator of the fraction, just to make it 100% clear what those are. Right. So now, but before we go on just to some examples, let's go over the variables here, just like we usually do when we get a new formula. A is the amount. Right, that is the future value, right? The value of the annuity at the end of the investment period. R is the interest rate, just like it was before. T is the time, also just like it was before. And N is the number of compounding periods. Again, just like it was with the compound interest formula. Right? If we're doing this monthly, there's 12 months in a year, so it's 12. Quarterly, 4 quarters in a year, so it's 4, and so on. The only difference we have in here, right, the only real new thing is this R. R is, think of it as regular, right? This is the regular payment amount. That was the $100 in our previous example. Okay, so now we've got our formula. Right, now we've got our annuity formula to work with. So just like we did with the compound interest situation, now we're going to, in the next lecture, we're going to take a look at some specific examples, see how that formula can be used.